The function f is defined by f with this definition. For x in the real number line such that x is bigger than or equal to 1. Find the inverse function f. Find the domain of the inverse function of f. The function g is defined by this here. Find f of g, f composite g of x, giving your answer in its simplest form. And find the range of f of g. So I've summarized all these parts here. So let's have a look at this then. The first thing to do is to get the inverse, isn't it? So here's the function, so it's here we see that it's y equals 4 minus ln x plus 2. So let's move this minus log over to this side and write it as a plus log. And then at the same time we'll move the y over to be with the 4 that's already there. And when we move it over, it flips sign to a minus y. Let's unwrap the log. This is log base e, so the e swings up and hits that in the air, so to speak. So we're left with just the x plus 2 when it's unwrapped is equal to e, because the e base number swings up, hits that in the air, e to the 4 minus y. And finally we see that x is equal to, move the 2 from here through the equals and flip the sign. So it's e to the 4 minus y minus 2. So there's our template then. So the inverse function f to the minus 1 of x is equal to, now flip the symbols, the x becomes the y here, the y becomes the x, e to the 4 minus x minus 2. So there's our inverse function. So that's part A. Now we need to find out the domain of the inverse function. Well, domain of the inverse is just the range, is equal to the range of the original function, the range of f. So what is the range of f? Well, we look at our function here. It was y equals 4 minus ln x plus 2, and this was for x bigger than or equal to minus 1, wasn't it? Let's just go back up and remind ourselves that that was the case. There it is there. Okay, so we've got this function then. So now you'll notice that the log function is an increasing function. If you think about a log function, here it is here, typically. It's increasing as it goes along. So the minus log function is decreasing, isn't it? So 4 take away a value will just be a decreasing function. So this is a decreasing function. Since f is decreasing, it's a decreasing function, continues to decrease, the range of f is, so let's write that down then. Well, the biggest value of f will be the value when you get the first value of x. Put in minus 1 here, you get log 1. Minus 1 in here, you get log 1, which is 0, so you're going to get 4, aren't you? So you're going to get 4 is the biggest value. And then it decreases, so that's the biggest value. The smallest value is minus infinity. So that's what we got then. It goes up to 4 from minus infinity. Which equals, so that is also, so that was minus infinity 4. So domain f of f is minus infinity 4. So that's part B done. So let's go back up then. The function g is defined by this, e to the x squared minus 2. Find f composite g in its simplest form, part C. So g of x is equal to e to the x squared minus 2, wasn't it? Remember that f of x is equal to 4 minus ln x plus 2. So we now want g, this is part C, and we want to work out, what was it? F composite g, or f composite g in its simplest form. So f composite g of x is equal to f of g of x. g of x is equal to e to the x squared minus 2, which is equal to f of, so it's 4 minus log of the something plus 2. Here's the something, put it in, plus 2. So what do we get here then? We get 4 minus ln, the 2's cancel, we get e to the x squared. Log of, so the power, use the power rule, the x squared is a power, jumps down to ground level. 4 minus x squared ln e. Log of e is 1, so it's simply 4 minus x squared. Okay, that's part C. Now part D asks for the range, doesn't it, I think? So find the range of f composite g. So f of g of x is equal to 4 minus x squared. Now the domain of g is the domain of this function. So the domain of g is x belonging to R, I believe, for g. Where is it? It's up here somewhere. I know that. Here it is here. X belongs to R. This is the domain of g. So this is a quadratic curve. Just do a little sketch of it. 4 minus x squared has the biggest value of 4, and it's an n-shaped curve, isn't it? Because it's a negative quadratic. So, range of f composite g is, well, it would go up to and touch 4, but it would go down to minus infinity, up to 4 and touching 4. So a little square bracket there to denote that the interval endpoint is included.